Welcome to statistic learning session today. I'll be talking about goodness of fit. The interesting we will be doing today is taking the we'll come to the MLE today. That's our goal. The goal of our session today is compute the MLE, and for that we have the likelihood a model as given as a P1 N1 times P2 N2 up to Pk in K. That's a model we have been given. Now we need to compute the MLE out of it. Now, obviously, the first step we need to do is what? Can you tell me? We need to take the log of this likelihood model. Now, if you take the log of this likelihood model, it becomes log ln, and it will be n1 log p1 plus nk log pk. That's what's going to be. Now, what we should do now to do this to get a maximum log likelihood, not just log likelihood, the maximum log likelihood. What's the next step we should do? Can you tell me? Just think about it. We should be taking the derivative of this and setting to 0 to compute the maximum log likelihood, and we'll be taking derivative against pz, the pz term. And if you take derivative against pz term, then it's going to be derivative of log ln against pz term will be nj nj divided by pj, and it will set it to 0. Now, can you see what's the problem going on here? Think about it. The problem is that if you do this, it means pj is equal to infinity. But we know that the sum of pj's, the sum of pj through 1 through n is 1. It's not infinity. That's a problem here. Now, what we should do is, for we have this k term, for k term, for pk, we will say that it's not an independent value, but it is a value that is 1 minus some of all previous values, k minus 1 and j equal to 1, that is pj. Now, if we do this, then we'll again take the derivative of that. Now, we need to do the derivative again, and what we get is the all the term beside the last term is going to be nj and pj minus nk, the last term, and we'll take derivative against 1j pj, and we'll set it equal to 0. That's what's going to be. And because of this, how many term we'll get? J is 1 to k minus 1. So we'll have a k minus 1 equations, and this is a constant. Because of this, nj pj will be equal to some value. Let's call it gamma for now. And when this happens, we'll do one thing. We have to we have to take this equation as pj and nj divided by gamma. Now we know that the sum of this pj is 1, therefore is same as taking nj, and it's a gamma, and sum of all the Ni is a n. Therefore, 1 so 1 is equal to n divided by gamma. Therefore, n is equal to gamma. That's what we get now. Now we also know that Pj is Nj divided by gamma. Now we know that gamma is n. Therefore, Nj equal to n. That's how we get this Pj is equal to n by n equation. And once we have this, we have completed our derivation process. Now let me quickly summarize what we learned today. We learned about multi-million likelihood. We started with a likelihood formula, a likelihood model for x1 through x1 a variable with probability with each of those. And we took derivative. We looked at natural log likelihood on top of that. And we found that it was not working for us because once if you took derivative of that against Pj, then Pj come out to be infinity. So we substitute the last Pj with the sum of the previous minus 1. And once we did that, it turned out to be okay. And we were able to get the Pj is equal to Nj divided by n. And this can be used to get the values for probability CDA, CDF4, all those CUs we had earlier. And it's a fairly natural estimator. So that's all for today. I'll see you next learning session. Thank you so much.